Right now, approximately half of all men over the age of 50 are losing their hair. Not all at once, not dramatically. Gradually, a retreat from the temples, a thinning at the crown, the slow reorganization of the scalp into a shape that is, across every culture on Earth, immediately recognizable. Half of all men, every ethnicity, every continent, every generation since ancient Egypt at minimum, and almost certainly long before. Here is the question that should have been asked a long time ago. If male pattern baldness reduces attractiveness, and research consistently confirms that most people rate bald heads as less attractive than a full head of hair, at least initially, why did evolution allow it to persist for tens of thousands of years in half the male population without eliminating it? The answer involves a genetic accident, a migration out of Africa, a hormone with an unexpected second job, and one theory that has nothing to do with hair at all. The conventional explanation is that male pattern baldness is simply a genetic flaw that evolution hasn't gotten around to fixing. It appeared, it spread, it doesn't kill anyone, so it persists. This explanation is incomplete, and the reasons it's incomplete tell you something genuinely interesting about how evolution works. Male pattern baldness, formerly called androgenetic alopecia, affects approximately 50% of men by age 50 and up to 80% of men by age 70. It follows a specific, predictable pattern. Recession at the temples, thinning at the crown, with the sides and back remaining largely unaffected. This pattern is consistent enough across individuals that it has a standardized classification scale. The mechanism is well understood. A hormone called dihydrotestosterone, DHT, is converted from testosterone in hair follicles by an enzyme called 5-alpha reductase. In follicles that are genetically sensitive to DHT, this hormone gradually miniaturizes the follicle over years of repeated growth cycles until it produces only fine, nearly invisible hair. The follicles on the top and front of the scalp carry more DHT receptors than follicles on the sides and back, which is why the pattern is consistent. What the mechanism doesn't explain is why the genetic sensitivity exists at all. Having DHT-sensitive follicles on your scalp provides no obvious survival advantage. Losing hair in a specific pattern doesn't make you a better hunter, a more efficient forager, or a more disease-resistant organism. So why does this sensitivity exist in half the male population? Why hasn't selection removed it? There are 4 possible answers in the scientific literature, and they are not mutually exclusive. The first involves a genetic accident during a migration that happened 40,000 years ago. The second involves a hormone doing a second job nobody expected. The third involves what bald heads signal to other humans, and the fourth involves sunlight, and may be the strangest of all. The distribution of male pattern baldness across global populations is not random. It is significantly more common in men of European and Middle Eastern descent than in men of East Asian or Sub-Saharan African descent. Studies comparing baldness rates across ethnic groups consistently find that European men bald more frequently, more severely, and at younger ages than men whose ancestors remained in Africa or migrated east rather than northwest. This uneven distribution has a genetic explanation. Researchers studying the global distribution of baldness-associated genetic variants have traced the highest concentration of these variants to populations descended from groups that migrated out of Africa into Europe and the Middle East, a migration that occurred roughly 40,000 years ago. The leading hypothesis is that the genetic variants responsible for the specific form of DHT sensitivity seen in European male pattern baldness were either absent or at very low frequency in the out-of-Africa founding population, and increased in frequency through a combination of genetic drift and possibly mild selection pressure after that migration of the entire group. Genetic drift means that when a small population splits from a larger one and moves to a new location, it carries only a subset of the original genetic variation. If the founding group happened to carry slightly higher frequencies of baldness-related variants, by chance, not by selection, those variants would become more common in all subsequent generations descended from that group. This is called a founder effect, and it means the specific form of baldness affecting millions of modern men may trace to a single ancestral population that moved northwest out of Africa, carrying a genetic variant they had no way of knowing would matter. The first prehistoric man to carry the full complement of DHT-sensitive follicle genes probably didn't go bald himself. Prehistoric life expectancy was short enough that many men never reached the ages where the trait fully expresses. But his descendants did, and their descendants, and eventually you. A genetic accident, preserved across 40,000 years, expressing itself for the first time in large numbers only when humans began routinely living long enough to experience it. Here is the piece of the baldness story that almost nobody discusses, and that changes how you think about why this persists. DHT is not primarily a hair hormone. Its main roles elsewhere in the body are significant and beneficial. During fetal development, DHT drives the differentiation of male genitalia. During puberty, it drives the development of secondary male characteristics, facial hair, voice deepening, muscle development, the maturation of the prostate. In adult men, it contributes to libido, bone density, and red blood cell production. DHT is, in other words, doing a great deal of important work throughout male development. The baldness it causes in genetically susceptible individuals is a side effect of a hormone that is otherwise essential. This is what geneticists call pleiotropy, a single gene or gene cluster influencing multiple traits simultaneously. The DHT pathway cannot easily be turned off in the scalp without affecting its function everywhere else. Men given 5-alpha reductase inhibitors, drugs that block the conversion of testosterone to DHT, used clinically to treat baldness, show consistent side effects including reduced libido, sexual dysfunction, and in some cases mood changes. You cannot separate the baldness from the hormone without losing some of what the hormone does. Which means evolution faces an impossible trade-off. To select against male pattern baldness, you would need to select against DHT sensitivity in scalp follicles specifically, but those genes are bundled with genes that drive normal male sexual development. Selecting against the bundle means selecting against reproduction itself. The baldness in this framework is not an evolutionary oversight. It is the unavoidable collateral damage of a hormone that is simultaneously essential. Now here is the theory that nobody in the popular literature is talking about, and that is increasingly taken seriously in evolutionary medicine. What if the bald scalp itself was doing something useful? In low sunlight environments, like Northern Europe, where the out of Africa migration was heading, vitamin D synthesis through skin exposure to UV radiation is a genuine biological priority. A bald scalp is a significantly larger surface area of sun-exposed skin than a hair-covered one. A bald head in low sunlight conditions may produce meaningfully more vitamin D than a full head of hair. The vitamin D hypothesis for male pattern baldness has been proposed by a small number of researchers in evolutionary medicine and has not been definitively tested. It remains speculative, but it is worth taking seriously. Here is the logic. The migration out of Africa into Europe moved human populations from high sunlight equatorial environments to low sunlight northern environments. In equatorial Africa, dark skin had evolved to protect against UV damage, but that same dark skin became a liability in northern latitudes where UV was scarce. It blocked the very radiation needed for vitamin D synthesis. One of the documented adaptations to northern environments is skin lightening. Populations in northern latitudes have systematically lighter skin than equatorial populations, which increases UV absorption in low sunlight conditions. A bald scalp is another potential adaptation in the same direction. More exposed skin surface, more UV absorption, more vitamin D production in an environment where vitamin D from food sources alone was insufficient. If DHT-sensitive hair loss was slightly more common in the founding European population by chance, and if that hair loss provided a small but real vitamin D advantage in northern latitudes, natural selection might have allowed those variants to persist, or even increased their frequency slightly, rather than eliminating them. This would explain why male pattern baldness is most common in populations descended from the European migration, rather than in populations that remained in high sunlight environments. The second angle is social. Research on perceptions of bald men finds a consistent pattern. Despite initial attractiveness penalties, bald men are rated as more dominant, more confident, and physically larger than the same men with hair. A 2012 study by social psychologist Albert Manns at the University of Pennsylvania found that shaved heads were consistently rated as more dominant, taller, and stronger than the same individual with hair. In a male dominance hierarchy, appearing more dominant has real social benefits. If a bald head signals age, maturity, and established status to other group members, the reproductive disadvantage of reduced initial attractiveness might be offset by social status gains, particularly in a species where social status is a significant predictor of reproductive success. The baldness may not be a defect, it may be a signal, one that 40,000 years of evolution has not found reason to silence. The founder effect hypothesis for European male pattern baldness is plausible but speculative. The genetic architecture of the trait involves over 600 genomic locations. Attributing its geographic distribution to a single ancestral bottleneck is an oversimplification of a complex picture. The vitamin D hypothesis has not been rigorously tested. It is an inference from population distribution data and the known biology of UV-driven vitamin D synthesis. A direct causal link between baldness genes and vitamin D production advantage has not been established. The dominant signaling hypothesis is based on perception studies in modern Western populations. Whether these perceptions reflect ancient evolved responses or modern cultural associations is not established. What is not in dispute, male pattern baldness is driven by DHT sensitivity in genetically susceptible follicles. The genetic variants are ancient and plausibly linked to the out of Africa migration pattern. DHT cannot be eliminated from the scalp without affecting its function elsewhere. The trait is too common and too persistent to be a simple evolutionary error. Something kept it there, the full explanation of what is still being assembled. So why did ancient humans start losing their hair? The genetic machinery for it is ancient, predating visible baldness by potentially tens of thousands of years, sitting quietly in the genome of populations that rarely lived long enough to express it. When humans began living longer, the trait appeared. When a founding population carried those genes into lower sunlight environments, the trait became more common. When DHT proved essential to development and reproduction, the trade-off that causes baldness became impossible to remove cleanly. Baldness was not selected for, it was not selected against. It was carried, invisibly, in the genetic cost of everything that makes male development work. The next time you notice a hairline doing something unwanted, your own or someone else's, recognize what you are actually looking at. Not a flaw, not an accident. The visible consequence of a hormone that built you, in a package that came with a cost that half of all men eventually pay. 40,000 years of history, still expressing itself, right on schedule. One question. Are you losing your hair, or have you already? And did you know about the vitamin D angle before this video? Drop it in the comments. This one is going to have an interesting comment section for obvious reasons. If this changed how you think about something you notice in the mirror, like button. And if you want to keep following the real origin stories, the evolutionary reasons behind the things happening in your body right now, subscribe. Next time, why you have nightmares, and why the things you dream about are almost identical to what your ancestors dreamed about 100,000 years ago. See you soon.